Hello, this is a video on calculating Boyle's law, which is one of the gas laws. What I have first up is the steps you need to go through to calculate any gas problem. And if you watched a previous one, you can skip through this minute or two. So, but if you haven't, what you need to do is you need to ask a few questions of the problem before you are actually writing things down. There was another video on the overview of gas calculations, and that's what the first two questions will help you with. The first question you always ask yourself in a gas problem is how many what I call conditions are there? In essence, are you doing anything to the gas? If you are doing something to the gas, like you see action verbs like cooling or compressing, then you know you have a two-step, what I call a two-condition problem. Condition one being the initial, what the balloon was in its four parameters initially, and then after you do something to the gas, what are the four parameters? If not, you just describing the balloon, and I call it a one condition problem. If you have a two condition problem, there's actually another question you ask yourself. What is being held constant in the question? And a lot of times you know it because they don't tell you anything about that parameter or variable. So then once you have that piece of information, then you know it's being held constant, and then you know what's varying. In the three gas laws and Avogadro's hypothesis, there's always two variables or parameters being held constant and two that are varying. Once you know this, you write down the information that you know, convert the information that you know into the correct units. Then you write down the correct mathematical relationship with x by itself and all the other variables, x being the unknown variable, and all the other variables on the other side of the equation. You plug in, do math, and then you get your answer in the right units, significant figures, and so forth. So that's the basic way of doing any gas problem. So for this one, we're specifically looking at Boyle's law. So, so with Boyle's law, you have to ask yourself: is Boyle's law one or two conditions? And Boyle's law is a condition, two condition. And you can see from the question that it says, if I decrease the pressure, there's my action verb, decrease. So the balloon is at an initial condition with the variables, and those are what the subscript 1 mean. And then you decrease the pressure, and then now you have the gas in a new condition, condition 2. And that's why it's subscript 2. For Boyle's law, by this time, most likely you have done the gas demonstrations or have determined what Boyle's law is. And what Boyle's law says is that if we hold temperature and number of moles, now constant, then pressure and volume vary in a certain way. From the demos or from the analogy that I give you about gas particles, where think of a room and there are people in the room, and the people in the room are gas particles. So they represent N, which is the number of moles. And the volume of the room, the size of the room, is V. T is how fast they are walking, meaning how many steps per second or cadence. And P is the number of overall hits on the wall of the room that these particles have. And of course, gas particles must follow the rules of gas particles, walking in a straight line, bouncing off the walls, and all that stuff. So therefore, if you hold the number of students constant and how fast they're walking, if I reduce the volume of the room, the number of hits on the wall is going to increase. So therefore, volume and pressure are inversely proportional. And with inversely proportional things, if you put all the variables at the same condition, so that would be V1 and P1 on the same side of the equal sign, for inversely proportional, you are multiplying those variables, because as one goes up, the other one has to go down, and the number must stay constant. So therefore, when you set up your mathematical equation, you will need your V1 and P1 to be both on the top. So that's why if you look at the equation, and now I'm kind of actually going off my steps, I'm telling you about the equation, which is okay. Then just make sure that you declare your variables. So therefore, the second volume, because that's what you're looking for in the question, is what's its new volume? Your second volume, which is V2, must be equal to your first volume, which makes sense, times a ratio of the pressures, because that's what's being changed, P1, P2. So the real question is, where do you put the P1? Because you know V1 is going to be here, and then you have P over P. As Boyle's law says, they're inversely proportional. And inversely proportional means if V1's on the top, P1's on the top. And you therefore know where P2 is because it's the only thing left to put, which is on the bottom. So there's your equation, okay? And that's the equation you're going to use. You're not going to set up a ratio of condition 1 equaling condition 2. This is the better way of doing it, and this is the way I want you to do it, okay? And one of the big reasons is the fact that you can just simply look at this ratio of pressure change to give an estimate of what your V2 is compared to V1. Okay, so therefore you need to, before you can plug in, you need to declare your variables. In this case, if you look, a lot of times these are like word problems where the first condition resides in one sentence. So it says it's the gas originally occupies V1 at 2.45 liters and has a pressure of 475 millimeters mercury. Okay. Now, do I need to change that into atmospheres? No. Since we're setting up a ratio here, as long as those as long as those pressure terms are the same, they'll cancel. So then it says I'm decreasing the pressure to 262 millimeters mercury. What's my new volume? So therefore, P2 is the 262 millimeters of mercury, and of course V2 is what we're looking for. So there it is. Since these two units are the same, you don't have to change them into atmospheres. Here's your equation. We talked about how do you get the equation. Okay, and then you plug in. The millimeters of mercury will cancel. You get liters, and then you get the one number with one more significant figure, and then you round to the significant figures. Now, if you wanted it in milliliters, what you would do is you would take the liters and then right here and change it into milliliters, and then your answer would be in milliliters. Okay, and that's how you do a Boyle's law calculation. Thank you.